Welcome to the next edition of Grid Forward Chats. I'm Bryce Yonker. Today we have with us Tim Allen. Tim is the CEO of PXiSE Energy Solutions. Tim, thanks for being on.
Bryce, thank you for having me on. Happy to be here and excited to have our discussion today.
So I see a few longer stints on your bio from SDG&E, Sempra, and some others. Tell us a bit about your background and what led you there to the helm at PXiSE.
My background started in Southern California, where I grew up and went to school. I started my career with San Diego Gas and Electric after I graduated as an electrical engineer from Cal Poly San Luis Obispo. Early in my career, I spent time working on substations, transmission planning, distribution operations. And then as my career progressed, I learned about the investor-owned utility business model and gained some really great experience working with a Cal ISO during the early days of renewable developers flooding the interconnection queue and the need for that reform from a serial process to a cluster process. After 8 years at SDG&E, I had the opportunity to move over to the independent power producer side of Sempra, which has had many names over the years. At the time, it was Sempra Generation. It evolved into Sempra Renewables. And there I spent 10 years helping develop, oversee the construction and the operations of the Sempra Renewables wind and solar fleet of independent power plants across the United States. And at the very tail end of that time, before Sempra sold that business, I started working on some interesting battery storage developments, put in some interconnection applications into the transmission queue, which is one of the topics we'll talk about today.
Great. Maybe give a brief overview on the organization there. Some of the listeners may not be familiar with the company. So what are you guys doing? What are you solving? What sort of capabilities are you bringing?
Yes, PXiSE Energy Solutions is a controls company. We're really focused on unlocking all of the barriers to a transition to a carbon-free grid. So we have control systems for microgrids, for power plants. We also have more of the distributed management systems where we can help orchestrate and control DERs. And then some machine learning to help optimize and integrate with other industrial processes or campuses looking to maximize the value of their renewable resources. We are a company of about 55 employees. We're wholly owned by Yokogawa, which purchased PXiSE from Sempra Energy, where it was founded back in 2015.
A busy area indeed. I've asked this question to others, but I think your perspective on it will be great. What sort of priorities are you seeing from the people that are managing and running the grid? What's at the top of their list?
One common one, I'm sure you've heard a lot, is keeping the grid reliable. And that's becoming more challenging as the globe is looking to reduce dependence on fossil fuel generation. Also, what the grid is seeing is an increasing demand for electricity with all of the investment into data centers for AI and clean transportation, electrifying homes, especially in places like California. So grid operators are really seeing their worlds change where generation used to be at the top on the transmission system and electricity flowed down to the load. And now the generators are distributed all the way down into the distribution system, and power is not flowing one way anymore. So that is by far what I see as the biggest priority is grid operators that used to have a very solid grasp on the direction of power flow, known fleet of generators that they could control, and they planned who was responsible for what. And now the numbers of generators are increasing exponentially, and the grid operators in the transmission system don't have visibility and control of all those generators down in the distribution system.
And we cover this a lot as well, but your perspective is right in the thick of it. So you didn't mention flexibility, but that's one of the key outcomes that grid operators are looking for amongst others. Why is it so critical that they're working to address this?
Flexibility is the key to being successful in a changing environment. As the environment changes, we're going into a world where we don't have specifications, we don't have policies, we don't have requirements well defined. And oftentimes these new developments rapidly evolve. And so what we see is installing DERs, especially batteries, for a particular use case. That use case may not be needed in the near term, 5 years, 10 years. Another use case might be needed. Also, the technology is evolving very quickly. And so the flexibility is really a key right now when it comes to deploying assets in the near term, but ensuring they deliver their maximum value over the long term.
And I've been impressed learning about the platform that you guys are deploying. You mentioned optimizing batteries and other resources. How are you seeing various solutions solved simultaneously? Take batteries as an example, or maybe some other types of resources that you'd like to dive into.
There's a couple areas I think of. One is a battery that's on the distribution system. And we've worked with a utility in California that put some batteries on their distribution system to address resiliency. Remote areas that are subject to high winds and fire danger, and these batteries are installed to be able to provide some resilience. What they recognized is that that's a use case that only is applicable during a small number of hours within the year. So they were able to get the batteries registered in the wholesale market and use those batteries during times of non-high winds, non-wildfire risk to participate in the market. And so that unlocks more value. It makes those resources do multiple jobs, and ultimately is more economic than having separate resources doing both of those jobs. Another example is we see a lot of batteries being installed in grids with high amounts of renewable energy or weak grids, maybe smaller grids, that are historically being installed for ramp rate control only of one solar plant or one wind plant. And we've done some really interesting work with the national labs and with the Guam Power Authority to show how a battery that's doing ramp rate control does benefit the grid. But that same battery, when it can control the frequency directly and be used for energy shifting, adds a lot more value. So that's two examples that we've learned from our past experience. And there's so many more out there. Really looking forward to hearing from other people on your show. There's just so many ways in which batteries can be unlocked for their full potential.
Yeah, I'll throw another one out to have you respond to. I think a lot of folks deploy for peak management, load shifting, these types of assets, and often those values are going to the end customer. But when you start bringing those values into the grid operator, how do you effectively balance the value allocation that comes from a resource that can be divided in so many different ways?
That's a great question. It's a common problem. It really comes down to aligning objectives. So if somebody is paid for the resource for a particular purpose, but it has the ability to support the grid, then utilities have to be creative in their pricing structures. It could be a rate structure. It could be, a program where customers own resources that can benefit the grid. And by enrolling, you can then offer those services back to the grid. So sometimes those come in the form of somebody who's gone out with a business model and aggregates these resources and sells them bundled back in. And then we've seen other utilities that have directly contracted with one of their customers to buy the energy. That benefits all of their ratepayers. So there's different ways to align those objectives. And that's really the key is if, somebody paid for something and then somebody else sees value in it, there has to be a mutually beneficial arrangement to unlock that full potential.
And I guess I'll ask one more. With you mentioned the proliferation of renewable energy and maybe distributed energy resources. Often that can come with some additional aspects of running the grid, right? Power quality, frequency management, voltage control. Are you seeing some more advanced capabilities in dispatching batteries or other distributed resources to be able to smooth the operations effectively in those ways?
Yes, there's definitely advancements in standards that are used. IEEE 1547 is one that's on its third or fourth revision. It's requiring these inverters to have newer capabilities. And then there's also corresponding standards out there like 2030.5 from the IEEE, which works very nicely with 1547. And that provides the ability to communicate with and control those resources. We're also working with some of the national labs and developing some more IP on using what we now have as really high speed internet to serve this new digital economy that we're in. Opens up some new possibilities to use internet for closed loop control, which is a fairly novel concept, but I do see that being part of the solution in the future.
All right, moving past functionality, maybe we'll talk a little bit about markets. You all either operate in or have good visibility into a number of places. So are there differences or similarities or some combination of both when you're talking about bringing these sorts of assets on the grid, whether it's an island, maybe a vertically integrated operator, a deregulated or an organized market? How are these different deployments impacting the better demonstrations of the solutions that you're seeing?
Yes, as you pointed out, we've worked on projects around the world. We're pretty active in Australia. We've worked in the Pacific Islands, in Asia, and of course in North America. And the similarities that I see is that everybody is looking to get the most value out of their resources. That could be the most revenue or the maximum amount of benefits. And so that's really the similarity. Now, when you get into the different types of structured utilities or grid operators, which in small islands, those are the same people, what you start seeing is that the technical requirements accelerate in the smaller grids and the grids with high penetration of intermittent resources. So you're going to start seeing DERs and batteries play a more critical role than just providing energy at the optimal time. In larger interconnected grids that have operating markets, there's still so much generation that the renewables and the battery systems are mostly managing energy. And if you look at the duck curve, for example, that was a focus on energy. You've got solar, it's producing power at the wrong time. And so what do? You take the battery, you fill it up, you move it over. And so that's managing energy. When on these smaller grids, when you start taking off all your synchronous generators, that's a completely different problem. And so that's one of the key differences is I see a lot of large utilities and strong organized markets, interconnected transmission systems, setting high RPS goals. Well, when a 20 megawatt or even a 10 megawatt island sets a 100% RPS goal, you've got one utility scale solar system and some batteries and you're there. And so those technical challenges of truly making that transition and going down to very minimal or no synchronous generators happens much faster on these smaller grids.
Maybe we'll take a step higher on a couple topic areas. And I wanted to talk a little about maybe rates. I think we've seen rate pressure in a number of locations, which is certainly not an outcome that end customers appreciate. How does a more modernized grid that effectively integrates the large portfolio of distributed resources and storage type assets also balance the outcome of affordability?
That's a great topic, and one that, if we look around the world, I've seen in Australia an approach there where AEMO, the grid operator and market operator, has run two pilot projects that we worked on to create a true DER marketplace that participates in the wholesale market. It's more advanced than what we see in the United States, where DERs can participate in some limited energy services. This was producing an end-to-end system where resources could be bid and dispatched based on economic dispatch. So it was a true market participation, real-time market participation by DERs. So that's one of the more innovative approaches that we've seen around the world to really unlock that problem where if you just go with your traditional rate making model, that changes very slowly. Working with investor-owned utilities and their commissions, a new rate structure could develop over 2 or 3 years. And this industry is moving so fast that by the time a new rate design is put in place, everything's changed again. And we're starting to see some of that in California. And the way to solve that is really one of the ways is to incentivize the right behavior. And that can be done through creating markets that distribution resources can participate in, putting the right limits on those markets so people can't manipulate them. It's very similar to what we saw in California during deregulation. Markets are good at lowering prices as long as you don't have any cracks in your design that can cause manipulation. Another thing that I've seen is buying that power back at a rate that benefits everybody. That's a controversial subject, but seeing that done in some munis and co-ops. So it's really case by case. The traditional rate case of changing rates over a long, drawn-out regulatory process is not fast enough to keep up with how fast things are changing currently. And that's my opinion.
Great. Well, we could tangent on that a long time, but I want to cover a topic we don't often get to cover around capacity utilization of grid assets. So if these infrastructure, whether it's transmission or distribution, are pushed more to their full use, that can certainly help on economics. But running the grids on those more narrow margins means that there's not as much of that flexibility to the sort of dynamic shifts that places might want to have. What would you say is a good way to strike that balance, especially leveraging these types of assets that you guys have such a front row seat to?
Capacity utilization is really it's a core problem that gets solved in many different industries, where you're looking to maximize the use of whatever resource you have, right? If you operate a hotel, you want beds full every night. If you operate a theater, you want seats full every night. So this idea of capacity utilization, now that there's the ability to shift energy with strategically located batteries, there's absolutely a way to use up all the capacity that you have. And so we really enjoy working with customers that are looking to use up all the capacity they have while they wait for those long regulatory processes necessary, rate-making processes necessary to increase capacity. And we did that with a utility in Western Australia, where very small town, not connected to the transmission system, they stopped allowing solar interconnections for rooftop solar because their grid was unstable. Now they had excess capacity on their system, but what they needed was a more coordinated dispatch of all the resources to keep the grid stable. And so that's where we came in and helped look at the resources, the capacity on the system, and optimized all those resources by shifting around the energy to not hit any limits. And I think there's a lot of opportunities for that, both on the transmission and the distribution system.
Costly distribution upgrades, frequent extreme weather events, demand surging from an onslaught of distributed energy resources adoption. Do these challenges sound familiar? If so, you need Virtual Peaker's cloud-based distributed energy platform. We're empowering modern utilities with next-generation virtual power plant solutions to maximize the value of DERs. The Virtual Peaker platform unifies all aspects of DER management, from DERMS to customer engagement and demand forecasting. Learn more at virtual-peaker.com.
Let's pivot a little bit to one of the newer areas of storage, and you can define it however you'd like, but I'll call it long duration storage. And so many of the deployments of batteries seems like they're sub 4 hour, sometimes even some quite a bit under that. What kind of solutions will we be seeing that are going to try to get at the mid and longer duration storage, and what else does that unlock as far as how we're managing our grid systems?
That's a great question. We're working with some of the flow battery companies. There's several on the market, different technologies that are looking at these longer duration use cases that are developing. One of the really exciting ones is an iron air battery that's targeting 100 hours of storage. There's more traditional ones like the iron flow and vanadium redox. They're looking at 8 to 10 hours, and really, it's the market opportunity. So California really set the market at 4 hours, and the biggest value of batteries in California was RA. It was the capacity product that currently exists in California. And to meet that, you had to have a 4 hour battery. And so really, that's what really set the market in motion. So the market drives what gets developed. Some of the forward-thinking companies with these flow batteries recognize the need for more of the capacity utilization, the energy shifting. If you think about a world where you're not using fuel as your primary fuel source, that you have in a tank or in a pipeline or coming from a river, a nuclear plant, whatever, you've got a pretty much infinite supply of fuel. Now you want to run your grid on resources that you can't get your fuel on demand, right? You know when the sun's going to shine. You sometimes know when the wind's going to blow. So now you've got to serve your energy 24/7. And that's where these long duration solutions come in. They're really more cost effective at that long duration energy shifting that's going to be needed to provide that 24/7 energy.
Great. Very, very dynamic space that we're super interested to see advancing. Let's pivot over to the federal incentive side of things, whether it's a tax incentive for projects that are being developed, various consumer rebates, the grants that are going to the grid, expanded loans. There's a lot of funds coming at this space from a lot of different angles. What kind of near and midterm impact do you anticipate these having on the system and on projects that you all are working towards?
Some of the impacts that we've seen already and that we anticipate revolve around supply chain constraints, skilled workers, training, lack of standards. Really, there's a financial push to accelerate deployment of technology. And what we've seen is that there's sometimes the technology is not ready. And so things get installed that aren't quite ready. One area that I'm seeing a lot of excitement around, but also a little bit of misunderstanding, is grid forming inverters. There's a lot of papers written on how they're going to be part of the solution of keeping the grid stable. But most of the grid forming inverters on the market today were designed to operate islanded grids. And so you get specs written that say, hey, I want all grid forming inverters. And the ones on the market commercially available are designed for islanding. They're not really designed to be grid connected. So that's an example of, that can cause a problem, but it also creates an opportunity that it does get solved over time. And in Australia, they've been incentivizing solar and batteries aggressively for quite a long time. And in the early days, some of the utilities we worked with there went through some of these struggles where they deployed technology, didn't quite do everything they wanted it to do, but they learned from it. They were able to develop training programs and standards, better specifications, and now they're getting much better results from the systems they're deploying today than they did, 5 or 7 years ago.
And kind of sticking at the federal level, but from another perspective, FERC Order 2x4, or whatever acronym folks are calling it, was a big move in bringing the value of aggregated distributed resources ahead. Whether it's that order or other federal policies or regulatory developments, either here in the U.S. or beyond, are folks starting to get a closer understanding of what those impacts are going to ultimately bring? I know that it seemed to leave a lot of questions before it got to the implementation side as far as what the real impacts were going to be.
Yes. I did mention earlier Australia and the pilot they're running with a full DER marketplace. I think they're really at the head of this in terms of figuring out what the challenges are and how that's going to impact existing resources. So they're being very careful about it. What I've seen in the U.S. is that most of the ISOs are really being cautious and taking their time, asking for extensions, creating small programs where DERs can participate. So I see this moving slower than people hope for, but it's a different world. Like I said, earlier in the conversation, there historically has been a manageable number of generators where the grid operators knew exactly where they were. They had a full network model of their transmission systems. They've got either reliability-based dispatch based on the number of lines in service and out of service, or a market that publishes prices based on congestion. That's very well understood. Now you go into a world where you don't have any of those resources. You don't have any of those tools. You don't have any of those capabilities down on the distribution system. And as a grid operator now, that's where, a majority of your generation is going to come from. It really is the collision of two worlds, the distribution world and the transmission world. And really, those two need to start coming together. Some of the tools used in the transmission system need to get adapted, and used down into the distribution system. And then some of the processes used in the transmission world and the generation world need to get implemented down in the distribution system. For example, generators on a market-based system have to report their outages, they have to schedule them, they have to have real-time updates if they have a failure and they're down and offline. Those are the types of things that can be driven down in the distribution system if you think about a world where more than half of your generation at any given time could be coming from these millions of distributed resources. Now that seems impossible to do, but you look at what's going on this digital transformation, data management, the use of AI, I really see this starting to come together in the future. It seems overwhelming, but the tools that are being developed today, and if people can start working together and take the learnings from the transmission system, bring them down to the distribution system, and vice versa, that's where I see this really starting to come together.
Great. So a final question here. Deploying batteries, while it is a new asset, it seems to fit rather comfortably in the utility model and grid operator, the way that they operate as far as the assets that they're used to installing. That said, how do you get the various parties, and I'll just list a few, the customers, the market organizers, the software providers, the aggregators, the regulators, the researchers. It's a big tent. How do you get everybody kind of rowing in a similar direction to bring this type of solution to a scale that really matters faster?
Yes, that's a great question. If you think about it, all of us in this industry, whether we're control systems like PXiSE, battery suppliers and manufacturers, inverter suppliers, utilities, we're all working towards the same goal. Right? This is all about transitioning the grid away from fossil fuels, decarbonizing the use of electricity, maximizing the use of the resources and the capacity to maintain reliable and affordable electricity. But every player in this ecosystem has a different internal motivation and how they participate. And so really it's about setting that common goal, getting people together from their different diverse backgrounds and experiences and working together to solve these problems. One example I see from just as a technology provider is the Unify Consortium, really led by NREL, funded by the federal government. And the whole purpose of the Unify Consortium is to say, hey, everyone's doing different things out there with these resources and how they communicate and what how they're being used. And they're encouraging people to come in and participate and run workshops and run tests in the labs to move towards some common alignment. So that's on the technology side. When it comes to the commercial side, that's oftentimes the harder part, and also the human side. There's really changing in an organization or in a industry that's done the same thing the same way for decades. In some cases, nearly a century when you think about George Westinghouse and the first generator he put on the grid. That is, again, it's this collaboration where you get everyone together. And that's some of the things I see Grid Forward doing, the conferences you put on, some of the technical organizations we see working together. And it's really that collaboration that is going to move us in the right direction.
Well, Tim, thanks so much for being on and sharing your perspectives on a rapidly evolving space. We appreciate your perspectives.
Bryce, it was a pleasure and really enjoyed our conversation today. Thank you.
Thanks again to our season sponsor, Virtual Peaker. If you enjoy Grid Forward Chats, please follow us on your favorite podcast platform, give us a like or a review, and tell your colleagues. You can listen to all episodes and learn more about our efforts to advance the grid at gridforward.org.